Hello everyone, this is Hao Yang from Reichenbach Hamil Company, and my topic is regarding the manufacturing technology and industry design. From the picture, you see the right side is a Chinese very famous architecture. You see this building is huge but short. It's just 3 or 4 floors inside. And from the left side, you see this a church from European countries. These churches are always very tall and with a very sharp uh, roof on the top. And why the difference? Because both buildings are used for worship of the god, but the design uh, type is quite different. And what is the reason? My answer is because of the manufacturing technology. And for example, in China, we use quite a lot of wood for the very important architectures. And in European countries, there are also a lot of trees. So it's not a problem to obtain this wood for construction. But in China, um, in the past 2000 of years, the metrology technique to of the metal are very well developed, and the heat treatment, the heat treatment processing knowledge is also good in China, in the old China, and so in this case, the Chinese people can make very good tools for wood. For example, if you want to make a saw to cut trees, you need a very tiny, a very thin blade, and on this blade you need to cut a lot of cutters on this saw. And when you cut a tree, this metal sheet will generate quite a lot of heat, and if the steel is not good enough, and this saw blade will break. So which means this saw in the old time is a high technique solutions. It's a high technique tools. So it's an in ancient China, people developed this saw. I think 2,000 years ago. It's a very well developed, and also this type of planning tool is also high technique tools. But compared with this woodwork tools, the tools for stones are much easier actually. For example, using this chisel, you will get some all the type of surface of a stone surface as a wish. Yeah? So with such kind of tools, European countries they get a lot of stones to construct the churches. Yeah. But stones, as we know, is always small, yeah, but very strong, of course. Yeah. So with this small element, if you want to construct a huge space, the dome structure is the only choice. Yeah. So then, in this case, you need on both sides to construct stone walls, and in the middle with this type of triangle stone to fix this space. Yeah. So that is the reason why in China quite low but huge structures, architecture structures are constructed. Yeah. But in European countries, these are very tall and with a sharp roof structures are constructed. Yeah. The, the core reason or the essential reason is because of these tools and actually because of the manufacturing technology. So if a wood maker needs to cut the slot with this type of tools, the only choice is to make this rectangular with a very sharp, yeah, with a very sharp angle or edge on the 4 points. Yeah, this is must be very sharp. Yeah. So then, in this case, this to make joint ventures, joints. These some joints to combine several some wood part together. This is a very normal, very traditional. But considering if you use this type of tools, then this tool is widely used on CNC machine. This is a cylinder, the cylinder structure. So in this case, to cut a slot, it's not possible to cut a very sharp edge, but the edge with a radian. So which means if you use this type of tools to cut a slot, so this slot on the 4 point, this must be with a circle on the 4 point. So in this case, it's necessary that the designers to optimize the designs. It's with this radian, with a radian on the corner, on each corners, and this will be much easier for the CNC machines and for this modern tools. So I mean, this is also a case that the manufacturing technology changed the design. And here is another example. This picture is the old design, very traditional and very classical design. And so why in the old time the wood maker carve a lot of you see a lot of details on the surface? Why not just a plain a very flat surface? Because if you use such kind of small tools, it's not easy job to cut such a flatness surface, because manually if you need to cut or to mill such a flat, it's not possible to make a very good accuracy. The final result will be a curve. Will be not a real flat surface. But you make, as a wood maker, you make also a lot of manual hours, maybe for example 10 hours for a flat. But if you use the chisels to cut, to remove a lot of materials, remove a lot of wood, to finally to build such a surface with a lot of pictures, a lot of sculptures. Also, you maybe take maybe 12 hours, just 2 hours more than to machine a flat a surface with a good flatness. So this is the reason why the wood maker would prefer to carve some sculptures on the surface. But as soon as this machine, this is so-called planing machine, as this machine is developed, people or the wood maker will very easily to machine such a flatness surface just several seconds. So which means the cost will be much reduced compared with these tools. So after this machining technique is well developed, so the design changed to this type. So with this flat board, the designers just assemble the very simple but very modern designs, very modern furnitures. So this is also another example that the manufacturing technique changed the design. And similar you can find for everywhere in the building, in the architecture designs. For example, in Paris, the Eiffel's tower, the steel tower. Why the designer make such a nice, or I would say strange design at that moment? Because the steel industry developed very well, and the price of steels reduced quite a lot. So people can use such a cheaper construction construction material to construct it or to build nice buildings and nice architectures. And in Europe, there are also many different steel structures for subways and for bridges, for many different things. Yeah, because because of the steel, it's become cheaper. Yeah. And now you can see there are quite a lot of modern architectures, yeah, and with this facade, this aluminum profile facade with a very complex shape. Because now people using 5-axis machining, yeah, to construct such complex bent aluminum profile for this facade, for this surface. And also because of the glass processing reduce the price, so the designer and the architecture studio will use a lot of such kind of construction materials. This is a very interesting film. You see from this video, okay, that this designer, they can develop such a complex surface of chair, and with a modern technique. For example, you see from this video, this designer, they can design the surface with some special robots, and they just make some points, and then the machine will know how to construct, how to build such a program. And you see this with this 5-axis machine, they can get a very smooth and high quality surface for this kind of chair. Because before, without this technique, the chairs is always sharp, and it's not easy to machine a very complex surface. Yeah. And this technique at the beginning is used for military and for aerospace, for example, for the turbine. But now this technique reduce the price, reduce the cost, and then even furniture companies can afford for this such kind of machine and software to construct this structure. So that is some examples that I share with you. I mean, you can really clearly tell the technique is really changed our world. And now, what I will say, what what will happening? Yeah, what is the next step? What is in the future? How the manufacturing technique will change our world? Yeah. So I will say the hybrid process is the future of a modern manufacturing, and the future is already came. And so we can tell the chance of the manufacturing technique. I would say this. Yeah, maybe someone say the 3D printing is the future, and also some maybe see the aerospace and the hard metal or the hard material could be the future. Yeah. But I would say very clearly change of the manufacturing technique is the function integration. Now I will give you an example. For example, this part, this steel part, if you this is kind of engine or some valve. If you want to machine such a part on a raw material, for example, a casted material, a casted steel, or the forged steel, these parts, raw parts, must go through for these different machines, different um, manual machines. For example, if you drill some holes on firstly you need the drillers on some drill machines, and then if you need to mill the surface, and then you must move this machine, this part to these milling machines, and then you have to always change from machine to machine, and it will make time a lot of time consuming. But after the CNC, the center, the machining center developed. All the function of these five machines combined in one machine. For example, this machine you can just in this machine you can finish the turning, milling, grinding, drilling, boring. All the machining process will be finished in one machine. In one CNC. So I would say this is very clearly this is function integration. You see, there is another video shows what we did now. It's also, I would say, the trend is also clear, and it's a function integration. In the past, we integrated the machining process together, like the turning, milling together. But now we are integration more different processings. For example, if you need to produce such part, maybe firstly you need 3D printing, laser with a laser or some other process to construct such a raw material, and then maybe you need to weld some other parts together, and to using the laser to drill some holes and to make the surface treatment or clean the surface. But also, yeah, one this part need to be changed from the machine to machine. But what we did now is we integrated these functions together. Now, for example, in this machine, you see it in the video, we finished. We integrated the machining, just a normal mechanical machining, and the 3D printing together. Yeah. In this video, you see we are repairing such blades with firstly with 3D printing, and then with 5-axis machining, and then you have a very nice surface. So then it's a very clear. I would say this is a kind of processing center, and there are more modern processes are integrated. For example, this 3D printing, and also using this laser, you can drill some holes and print some words on some letters on the surface, and also you can weld some parts together. Yeah, and also it's possible to coat on the basic materials some other different materials. And also it's possible to integrate with ultrasonic cutting, ultrasonic welding, all this type of different processing together, integration in one machine. So this is the future. Actually, it's not the future. We already realized this idea. Yeah. So I call this processing center. And so I would say this processing center, that all this technique is well developed, and we developed the first so-called hybrid processing CNC. In this we had made a lot of tests on with this laser claying process, and with the five-axis machining together. And this machine had already developed 5 years ago, and now it works well to repair the blade and some very high value parts. And just several months ago, we developed this resin or the plastic 3D printing with a five-axis machine. And so now we have both solutions for metal work and also for non-metal works. And we think this is this is the future. And if you are a designer with this machine, you can realize all kinds of complex structure. Yeah. So your imagination will be not limited by the machining process. And also, this is the picture for our new machines, 3D printing combined or hybridated with the five-axis machining. So this new technique gave us a new hope. If you are a designer, you don't have to assemble such a lot of small, tiny things on your model. With such a machine, such a hybrid processing machine, you just need to input your 3D file, and then the machine will translate this 3D model to the NC code, and the machine can make firstly with the five-axis mechanical machining tool to get a rough shape of this structure, and quite a lot of detailed structures, detailed small things can be printed with the 3D printing head. You know? And for example, for this part is made of one block or several block with our machine, and you can see already this the accuracy is high enough. But for these small things, these sculptures and some tiny trees and some metal, these metal things assembled manually. Then in this case, this accuracy reduced. But with such kind of machines, you don't have to worry about this assembly. One machine will finish all the jobs. So you see from these videos, this is a huge gantry machine combined with 3D printing and five-axis machining. Okay, the first step is this machine construct the raw material, and then they change the five-axis machine and change the tools and mill, and to get a very nice surface. You see, this is the first step, and the second step. And second step, is using the five-axis mechanical machining, the traditional machining way, to get the fine surface. And this process will be used for many different industries and markets. For example, some art, especially for some art piece. This is our one of our customers from UK, and you see this metal is very this caustic metal can firstly used with a foam as a vanishing mold, and then they input the alloy inside the mold, and then using the machine to get such a fine surface, and then polish that, and then combine the stone with this metal parts together, and finally this is a very nice art of piece. And then this art piece is made for Hong Kong bank, and it's now if you go to Hong Kong, you can see this sculpture. It's also used similar used by the similar machines. By the similar, I mean just a high accuracy 5-axis machines for the polishing the surface. And also with the machine, with the more modern manufacturing technique, you can make a very tiny sculpture with machine without manually. Yeah, so it's really good news for the designers. If you just have ideas, you don't even make this sculpture by yourself. Just give this job to the machine and give these jobs to the modern manufacturing technology. Then let's come back to our topic. This new technique, this new manufacturing solution will change our world continuously. Yeah. For example, with this hybrid processing, you can produce, you can construct artificial bones with hollow or complex structure inside, and from outside you print more density of metals, and with high accuracy tools you can have a very fine smooth surface. Yeah. And also you can coat or to make the heat treatment for some metals, for some high accuracy parts, and also to repair these tools, these dies. And also you can construct a new lighter and a better rigidity of these bones, artificial bones. Everything is possible. And this is also we can use this technique in different ways, for especially for design, for architectural model making. Yeah. So the designers will not you don't have to think about how to realize such a models. You don't have to you don't need to think, okay, this process, this model seems quite complex, and we need very good workers, good people to assemble all these small parts, and also we need a very high skilled sculpture to carve all these details on the surface. Now I tell you, this machine, this new this hybrid processing technology will solve everything. You know? So in this case, this world will be greatly changed by this new tech. Also with VR technique, you can just use the pad or the VR glass to have a better surface and better surface on this model. And we can help. We can make this VR or the AR solution much better. Which means we can with this manufacturing technique, this model or this new design will have a much better detail on the surface. And then with this VR and AR technique, this model, this digital model will give you a new feeling. So thank you very much for listening. So if you want to get more information regarding hybrid processing and the trend of manufacturing technique, and how this world will be changed by the potential manufacturing technology, you can just scan the QR code to add my connections. Thank you very much.